Did you know that our sun can stay completely silent for years before unleashing a monster flare that could cripple our entire planet? Well, that silence just ended, and what happened next will blow your mind. Join me as I dive into the mystery of the sun's monster flare that just erupted after years of silence. Hey cosmic explorers, I'm Mellori from Mellori Inspires, where we explore the wonders of the universe together, one mystery at a time. Today, we're diving deep into something that has scientists around the world scrambling to understand its implications. But here's what makes this particular flare absolutely terrifying. For years, our star, the sun, had been quiet, its activity lulled, sunspots few and far between. Scientists tracked this calm, our world growing comfortable, satellites and power grids running smoothly. But on May 14, 2025, everything changed. A region of the sun, charged with magnetic tension, erupted in a violent X2.7- class solar flare. The silence was shattered. The sun had roared awake. High-frequency radio signals on Earth's sunlit side vanished instantly. Pilots lost contact with air traffic control. Emergency broadcasters faced dead air, and confusion spread as vital signals were swallowed by the flare's radiation. This was just the beginning. A warning shot from our star. We'd been lulled into a false sense of security, building our world on the assumption of calm cosmic weather. The X2.7 flare was a jolt, a wake-up call that the sun was entering a new turbulent season. Our technological civilization was suddenly vulnerable, reminded of the immense power just 93 million miles away. The smooth ride was over. The sun had put us on notice. We were awake now too. So, what is a solar flare? It's a colossal explosion of energy on the sun's surface, triggered when tangled magnetic fields suddenly snap and reconnect. The energy released equals millions of hydrogen bombs, sending X-rays and ultraviolet radiation racing toward Earth at light speed. These flares originate in sunspots, visible signs of magnetic chaos on the sun. When the flare's radiation hits Earth, it ionizes our upper atmosphere, disrupting the ionosphere and causing radio blackouts across the sunlit side. Long-distance communication fails, affecting aviation, maritime operations, and emergency services. But the flare is just the start. Often it's followed by a coronal mass ejection, a massive bubble of plasma and magnetic field hurled into space. If a CME is aimed at Earth, it can arrive in days, triggering geomagnetic storms that threaten power grids, satellites, and astronauts. The flare is the flash. The CME is the cannonball. Together, they can disrupt our world in ways we're only beginning to understand. To understand solar flares, we must look at the sun's magnetic fields. The sun, a ball of plasma, spins unevenly, its equator faster than its poles, twisting magnetic field lines into knots. These tangled lines break through the surface as sunspots, marking regions of intense magnetic stress. Convection churns the plasma, twisting the fields tighter until they snap in a process called magnetic reconnection. This snap releases vast energy, accelerating particles and emitting radiation from radio waves to X-rays. The most powerful flares, X-class, can unleash more energy in minutes than humanity has used in its entire history. All from a single localized region on the sun. It's a cosmic reminder, we are linked to the sun's life and fury. The forces at play are immense, and their effects reach all the way to Earth. Our technology and lives are inextricably tied to this stellar drama. The sun's outbursts are not just distant phenomena. They shape our world. The X2.7 flare of May 14, 2025 was a shock after a long solar lull. Scientists expected a quiet solar cycle, but this flare shattered that illusion. The radio blackout was immediate. Aviation, maritime, and emergency communications on the sunlit side failed for over an hour. Pilots lost contact, forced to rely on backup systems, highlighting real-world vulnerabilities. For astronauts, the danger was personal. They moved to shielded areas to avoid radiation exposure. The event was a stress test for our global infrastructure. It showed how quickly our systems can be disrupted by the sun's fury. The flare was a wake-up call for scientists, engineers, and everyone who depends on technology. The sun's unpredictability had real, immediate consequences. The flare's CME brought a different spectacle, a geomagnetic storm that struck Earth 2 days later. Our magnetosphere was buffeted, triggering a G4 severe storm and expanding the auroras far beyond the poles. People in places like Germany, the central US, and northern China witnessed breathtaking auroras, curtains of green, pink, and red dancing across the sky. It was a moment of awe, a visible reminder of our connection to the cosmos. But beneath the beauty, danger lurked. The same particles lighting up the sky induced currents in power lines and pipelines, pushing grid operators to the brink. Protective measures were needed to prevent blackouts. The event was both a source of wonder and a grave warning. It showed the power of geomagnetic storms and the chaos a stronger one could unleash. The sun's beauty and danger arrived hand in hand. May 2025. The solar event was a warning. We dodged a much bigger bullet. Our civilization depends on satellites and electricity, both vulnerable to solar storms. GPS isn't just for directions. It underpins finance, communications, and power grids. A major storm could damage satellites, disrupt global networks, and send supply chains into chaos. On the ground, geomagnetic storms induce currents in power lines, threatening transformers and risking blackouts that could last months or years. The Carrington event of 1859, when technology was primitive, set telegraph offices on fire. A similar storm today would be catastrophic, with trillions in damages. The X2, 7 flare and G4 storm exposed our vulnerabilities. We need better space weather prediction, hardened infrastructure, and robust contingency plans. Our digital world is fragile, and the sun's next outburst could test it like never before. The time to prepare is now. The Great Solar Storm of May 2025 is over, but its lessons remain. We are not just observers, we live within the sun's dynamic, sometimes violent embrace. As our reliance on technology grows, so does our vulnerability to space weather. The sun is awakening and more flares and storms are coming. We must invest in science prediction and resilient infrastructure. Missions like the Solar Dynamics Observatory are vital as are new ways to shield satellites and power grids. But beyond preparation, there's a call to curiosity. The sun is our life giver, not our enemy. By studying it, we learn about the universe and our place within it. Let the 2025 flare inspire a new generation to unravel the sun's mysteries. Our future depends on understanding and respecting the magnificent star we call home. What do you think about solar flares and their potential impact on our world? Share your thoughts in the comments below. If you're ready to explore more cosmic mysteries that could change everything we know about our universe, subscribe to join our family of space explorers, and hit that notification bell so you never miss out on our next cosmic video. Thanks for watching. I can't wait to see you in our next space adventure. The universe will still be full of mysteries tomorrow, and we'll help each other share them even better. Copyright 2025 Mellori Hope Carrington trademark, all rights reserved.